Our lucky last learning objective is to describe the 3 energy systems which fuel muscle contraction. So our muscles use ATP, or adenosine triphosphate, to fuel muscle contraction. We spoke about this when we looked at cross-bridge cycling. When we break down ATP as part of cross-bridge cycling, ATP breaks down into ADP, or adenosine diphosphate, and a phosphate ion. When ATP is broken down, energy is released. And this is the only energy source which is used for muscle contraction. Now, there are 3 energy systems that produce ATP for us to use during muscle contraction. The first one is called the ATP-CP, or the adenosine triphosphate creatine phosphate system. So creatine phosphate, which you might also see written or referred to as phosphocreatine, it's the same thing, is a substance which is stored in the muscle, which the body can use to regenerate ATP or turn ADP back into ATP, so the form that we can actually use for muscle contraction. So when creatine phosphate is broken down, it becomes creatine and a phosphate ion. That phosphate ion can then combine with ADP to form ATP, or adenosine triphosphate, and creatine. So this useful form of energy. Now, because creatine phosphate is stored in the muscle, no oxygen is required for this process to take place, and it occurs really quickly. However, the total store of creatine phosphate in the muscle is only very small, so we only produce 1 molecule of ATP per cycle, and this only provides energy for approximately 15 seconds of muscular activity. So this system will fuel muscular contraction in activities that are high intensity but of short duration. So think activities like sprinting or heavy weightlifting. The second energy system that we can use to fuel muscle contraction is called anaerobic glycolysis. And in this system, glucose in the blood is broken down. And when we break down glucose, it's called glycolysis, to form 2 ATP molecules and 2 pyruvic acid molecules, which is then converted to lactic acid. Now, the process of glycolysis is really complicated, and it involves the actions of a number of enzymes, which we are not required to go into for this unit. What I do want you to know is that anaerobic glycolysis happens really quickly. It can be undertaken without the involvement of oxygen, so hence the term anaerobic, referring to the fact it doesn't need oxygen. And it provides energy for around 15 to 2 minutes of exercise. So think our moderate to high intensity activities, such as a 200 to a 400 metre race or any repeated efforts in a team sport. The final energy system that our body uses to produce ATP for muscle contraction is the aerobic system. And the aerobic system is used to produce ATP at rest and during low to moderate intensity exercise. The aerobic system also uses a variety of processes to generate ATP, which, like anaerobic glycolysis, are beyond the scope of this unit. However, just for interest's sake, these processes include aerobic glycolysis, the Krebs cycle, and the electron train transport chain. Just in case you come across any of these terms and you're wondering what they're referring to. Now, the aerobic system produces ATP from a variety of fuel stores. So it can use carbohydrate, it can use fat, and it can use protein to produce ATP. Although it will preferentially first use carbohydrate and then fat. Oxygen is required for this system, hence the term aerobic, referring to the fact that oxygen is required. And we produce approximately 36 to 38 ATP molecules from the breakdown of one glucose molecule using this system. That being said, ATP will continue to be produced for as long as oxygen is present and that our fuel stores aren't depleted. So this energy system will be used all day when we're at rest, as well as during any low intensity or longer duration activities. So going for a walk, as well as day-to-day activities like hanging the washing on the line or perhaps cooking dinner. And finally, another table, just because I think they're such a great way to summarize and condense information. And so up the top here, we have the 3 energy systems that you need to be aware of. Down the side, we have the characteristics of each energy system that I would like you to know. So we have the fuel source for each system, the duration of energy that each system provides, the intensity of exercise for which each system can provide energy, whether or not oxygen is required, and approximately how many molecules of ATP are produced with each cycle.